Now, as we have learned about quantile plot, now the next plot we draw is a quantile plot. It is similar to a quantile plot, but it is used to compare one quantile against the another. So with the help of this plot, we can compare two products. As you can see, here we are comparing price of branch 1 with the price of branch 2. So quantile plot can be used for comparison purpose. So let us see how we can make use of this quantile plot using Excel. So here you can see the data. This data is some data 44, 48, 49, 50, 51. As you can see, we have once again arranged the data in an increasing order, and then this increasing order is signified by the attribute rank. So there is around 49 data values which are arranged in an increasing order. Now, in order to compare this data with the actual data of normal distribution, how we will perform that, we will just see. So first of all, we find out the percentile, as we have seen how to find percentile in the Q plot. So what we do is this B2 minus 0.5. So what this B2 is the rank of the data. That means we, after arranging the data into an increasing order, then we use that data, subtract minus 0.5 from that, and then divide it by the total number of records. So this computes the percentile value, which we have also seen earlier. After computing the percentile value, what we do is we find out the standard deviation of this data and the average of this data using MS Excel formulas. So since the data lies between A2 to A50, so that is my range, and with the help of these two formulas of standard deviation and average, I have found both these two because I want to find out the Z score. So in order to find the Z score, as you can see in column F, this Z score is evaluated using standardized function of MS Excel, where we use the first data as the A2. So this is the data we want to find the Z score value of, and with the standardized function along with the data, what we require the values of the average and the standard deviation, which we have already computed in row D3 and row D2. So D2 computes standard deviation and D3 rows compute the average. So we have put D3 and D2. That means first we write average and then we write the standard deviation. Because we do not want to change the rows of standard deviation and average, we have put a dollar symbol so that when we drag the function, then these rows remain the same, but the value of A2 changes from A2 to A3, A4, A4 in a similar way. So as here you can see the value for this function is A3, but the rows D3 and D2 remain the same. So in this way we can compute the Z score value from a particular data. Now, if as we have learned that QQ plot is used to compare two data values, so here we'll be comparing this data whether this data follows a normal distribution or not. So here I have computed the Z score value of a normal distribution. So these values can be computed with the help of function norm S inverse. So these are theoretical values of the any binomial distribution. So this is the theoretical value of the binomial distribution, and this Z score is the actual value of our data. So what we want to do here is actually we want to compare whether our data follows a binomial distribution or not. So when we plot these two values, Z score and score values, we get a graph similar to this graph. So here we can see that this Z score is the score computed from the values of the data, and this line is of the theoretical Z score. So we can see that the Z score of the data is is along the line. So most of the data follows along the line. So we can say that this data follows the normal distribution, because the line of the normal distribution, this is from the theoretical Z score value which we had computed using norm S inverse, and these blue dots are for the Z score value which we have computed from the values of the data. So since the data lies almost in the line, only small part of the data is not aligned with the line, but most of the part is aligned with the line, we can say that the data is normally distributed. Thanks for watching.